Lester SOLBAKKEN. And he is the guy, if you're thinking about ranking, and if you're thinking about using artificial intelligence for this sort of things, then you should listen to him. He works for Verizon Media. He's actually the principal software engineer there on the platform, which is called Vespa, that is specialized in big data handling. So welcome to us, Lester. How are you?
Thanks for coming, all. So as mentioned, my name is Lester SOLBAKKEN. I work as a principal software engineer, primarily focused on machine learning solutions at Verizon Media Group at the Vespa team. And today I thought I'd talk a little bit about a fun project we did some time ago called ranking article comments using reinforcement learning. And by article comments, what I mean is, you have these news sites and you have these article or these comment sections on these news sites. But what I'm going to talk about is also relevant for more social sites, with the Reddit, Hacker News, those kind of sites. But I guess also for product reviews on e-commerce sites and so on. So anyway, the goal of the project is to come up with some way of ordering or ranking comments in some way to increase user engagement. And I thought I'd go through both the science and solution architecture to kind of, show how such systems can actually be built. So first of all, if you're not familiar with the Verizon Media Group, it was a merger of Yahoo and AOL some time ago. They were acquired by Verizon, and we became the Verizon Media Group. Verizon Media Group is a sort of a technology provider to a number of websites that was under kind of umbrella of Yahoo and AOL previously, but also into Verizon at large as well. However, as mentioned, I work on the Vespa team in Verizon Media Group, and Vespa is what we call the open source big data query engine. So it's not this kind of stylish Italian moped, but it's named after sort of acronym, the Vertical Search Platform Architecture. And it's a platform used when you need to do kind of fast computation at query time over large data sets that might be evolving or changing over time. And point being that it has a rich set of features for many types of applications, such as the one that we're going to go through today, which is the comment ranking system, such as searching for relevant comments, scoring, ranking dynamically using tensors and machine learning models. Vespa has excellent support for many machine learning platforms such as TensorFlow, XGBoost, LightGBM, and so on. It's fast, it's scalable. This is a system that's under heavy use, which we'll see a little bit later. Also supports real-time writes, partial updates for immediately surfacing, reactions to comments, such as upvotes and downvotes and so on. So we'll be using a lot of these features in the system. Just some other typical Vespa use cases, just to kind of give you an idea what it's about. Text search. Vespa does traditional information retrieval, but is really more geared toward modern information retrieval, where we use vector representations, nearest neighbors, machine learning models, and use those to find relevant content. It can be used for recommendation, finding similar content using vector representations. Personalization, where we search using a user profile as a query. Question answering, instead of 10 blue links for a query, as a result for query, we can provide exact answers to questions using language understanding models such as BERT. Semi-structured navigation is combining search with filtering and grouping on metadata, for instance, for e-commerce sites, to refine searching to certain categories, price ranges, brands, or so on. Even finding love. There's a testimonial from OkCupid here, one of the largest dating sites online, which use Vespa for doing matchmaking online. Vespa was developed at Yahoo over many years before it was open sourced. There it was very popular and heavy use. At any given time, it's serving hundreds of thousands, I think over 500,000 to thousands of queries per second at any given time all over the world, over billions of content items, really. Hundreds of millions of users are using it. empowers things like Flickr image search. On the right-hand side here, we have an example of the front page of Yahoo, where you have many different widgets that are running. A lot of them are running Vespa at some degree. To the left, you have this personalized stream of news, which is running on Vespa. And also you get these native ads in that stream that's running on Gemini, which I believe is the third largest ad network in the world after Google and Facebook, naturally, and where Vespa performs this real-time bidding and so on to do all this. Okay, enough of Vespa for now. Back to the task at hand. Comments and comment sections. Vespa serves those as well. I kind of just want to start with a kind of short disclaimer, and that for right now, the comment sections on Yahoo are temporarily disabled. I'm not actually sure why. So this example here is kind of an example of an older news article, but it's in redevelopment before we are kind of putting this back online. So anyway, with that out of the way, comment sections, the reason we have them is to increase user engagement, really. So for instance, if we have good comments, they can add something to the topic, possibly add some sort of insights, gives ability to ask questions, receive answers, or in general comments that in general pique your interest or curiosity in some way. However, many comments, if not most, unfortunately, can really be bad. I mean, comments that are off topic, personal attacks, attempts at bad humor, and so on. But that's okay. I mean, people are people. But some comments might not be okay. I mean, like hate speech, racist slurs, spreading of misinformation, and so on. So our assumption is that to kind of increase engagement, we want these kind of good comments, these interesting comments. We want them to kind of flow up to the top in this ordering or this ranking of comments, and to promote them in some way. And these bad comments, we might want to kind of sink down a little bit. So this becomes a ranking problem, really. The problem is we don't really know how to define interestingness of the comments. We can't write an algorithm to do this. So we need to employ some form of machine learning, something that can evolve over time to follow the community in some way. And we're going to be using reinforcement learning for that here. Now, before starting this project, we had an existing solution, kind of a baseline. And we've had comment sections on the site for a long time. And it's always been fairly popular on Yahoo sites, especially on properties such as finance, news, and sports within the Yahoo system. And we have about 1 billion comments stored, serving 12,000 queries per second. There's a lot of traffic. And twice that for updates. Updates are things like upvotes and downvotes and so on. And some articles can even have like hundreds of thousands of comments. So it's pretty big. So when building a new solution based on machine learning, we need to kind of take a look at what features we have available. So we have these community features, and these are things like upvotes and downvotes and replies and so on, as a proxy for how the community liked the comment. And there's different ways of measuring this, upvotes minus downvotes, upvotes divided by the total amount of votes. But we use the Wilson score, which is fairly popular, which is more of a statistical method based on confidence intervals. Then we have features based on the content of the comments, such as relevance to the topic, which uses some sort of semantic representation to score the similarity between the comment and the article. For moderation, we use the Perspective API, which runs a sort of convolutional neural network over the text of a comment to return a toxicity score. Obviously, that's a fairly toxic comment down there. In addition, the system keeps track of repetition of each comment each author uses as a feature as well. Some other features we use as well as freshness of the comment. I mean, when was it actually commented? The previous ranking algorithm that we started from featured a rather kind of simplistic model. It was linearly weighted, hard-coded, and comments were just sorted in descending order of this kind of score. And this is kind of what we want to improve. So initially, the model weighted these features equally because we don't really want to assume which feature is most important. Ideally, we want to kind of learn this. But to do that, what kind of tools do we have? Well, we could do this manually using kind of A/B testing, running in buckets over days or maybe a week to get a statistically significant measurement using cross-validation and so on. But that's kind of slow, doesn't really scale. So we really wanted to kind of approach this using a machine learning approach that learns directly from user interactions instead. So in moving towards a new solution, we need to kind of take a little step back here and look at the kind of three major components that we want to kind of attack with this. And one is the scoring. I mean, taking a comment and giving it some sort of score that we use in ranking. And ranking is how we take those scores and actually produce an ordering of these comments. And learning is how do we kind of learn directly from user interactions or behavior from these rankings. So for scoring these different features, how could we combine them intelligently? Something that captures the kind of nonlinear relationships. Ideally, this thing like the Wilson score I mentioned earlier should be learned automatically. Should learn how to balance out toxicity and hate speech and so on. So we're going to employ a neural network to do this using some deep learning techniques. For ranking, we have this thing called a position bias. And when we're using neural networks, in order to kind of train neural networks, we need labels. Problem is we don't really get labels directly from comments. I mean, we don't show users one comment at a time and get feedback from them. Instead, we show a list of comments, right? And the problem with lists is that not everybody reads everything on the list. They don't go all the way to the bottom. Some people abandon it pretty early and so on. So kind of any label that we can infer from these interactions has this position bias. People generally pay more attention to the items on top. You see this problem for search as well. So ideally what we'd like to do is show people all the possible combinations of these orderings. There's way too many combinations to consider. Since instead we use sampling and use some sort of exploration technique to do that. And I'll show you a little bit later how this is actually done. And for learning, how do we actually learn directly from user behavior? And what we'd like to do is to do that from raw instrumentation if possible. And in this project, we use a dwell time, which is just measuring the time spent the user spends on these comments and use that as kind of a reward signal. We want to keep learning over time as the community kind of develops and shifts. So we're using reinforcement learning to kind of continually keep our model up to shape. All right, so let's step back a little bit more and introduce the reinforcement learning that we'll be using. So there's a difference between reinforcement learning and supervised and unsupervised learning that you're probably familiar with. I mean, supervised and unsupervised learning, they're more statistical techniques to learn models based on data, where for supervised, we try to find a mapping between input and output values. And for unsupervised learning, we try to find patterns in data and so on. But for reinforcement learning, it's a bit more AI-ish, if you will. So basically the premise is that we have some sort of environment. We have an agent in this environment, and this agent produces actions within this environment. And the actions, change this environment a little bit, and the actions or the agents can perform new actions, and this goes, around in the loop. And once in a while, the environment produces some form of reward to the agent that it's been doing something good or something bad they can learn from. And the problem is that this reward can be kind of sparse or very infrequent. So for instance, if you have a game-playing agent, such as for chess, then you won't see the reward until all the way at the end of the game, if you won or you lost the game, right? So the problem is kind of, tracking this signal all the way back through all the moves in the game to figure out which games we're defining in this win or this loss. And it can be, problematic. And that's called the credit assignment problem, which is something you need to tackle when using reinforcement learning in general. But if we remove the credit assignment problem and that we kind of always receive a reward based on the action that we take, we can reduce the problem to something called contextual bandits. Contextual bandits are an extension of the multi-armed bandit problem. And the metaphor here is that you have like a long line of these one-armed bandits or these slot machines, and each of these slot machines have a different payout. And your task is to kind of maximize your total payout over a number of trials. And to do that, you need to kind of explore which machines give a better payout and then exploit this when you get enough information. It's called exploration-exploitation dilemma. Contextual bandits expand upon this with side information or context that helps choose these kind of slot machines or actions. So this context is really just a feature vector or a set of numbers. And based on this vector, you can choose an action. And the process of choosing an action from this set of features is called a policy. And policy involves calculating some score for each action and using that score to choose an action. So for instance, the policy that selects the action with the highest score would be an exploitative policy, or a policy that always chooses at random would be an explorative policy. And usually you want something in between. You would think that since you always get feedback from an action, that this reduces to a supervised learning approach that we were talking about earlier, but you can't, because the reward is conditioned on the chosen action, which means that you choose an action, you get a reward, that's fine, but you don't know what reward you could have gotten if you chose one of the other actions. So you need this process of exploration and exploitation to be able to learn from this. And the canonical example here is ad serving on web pages. So if you have a web page, then the content on the web page, for instance, and the user together form a context. And the different ads that you can show on this page are the slot machines. And the goal is to learn over time how to show the best ad given the context. Now this can quite simply be extended to ranking, and but here the policy doesn't choose a single action, but it chooses an ordering or ranking of actions. And as I mentioned previously, the problem is that users don't really interact with the entire ranking. It's probably only the top or the first set of actions in this ranking. And this is the position bias we talked about earlier. And to learn from this, we need something called unbiased estimates. And we use a technique called importance weighted sampling, which I'll be showing a little bit earlier to see how we actually do this. Okay, so let's become a little bit more concrete. That was a lot of theory at once. So let's kind of show an example of what we're trying to achieve. So let's start with a comment. We want to give that a score. We have all these features that we mentioned earlier. And then we send this through this neural network that takes the features as input and has these parameters or theta that we want to train. And it results in a positive score. So quite simply, that's how we score each comment. Each comment goes through this neural network using its features. For ranking, we have a number of different comments, and each of them get their own scores using that process. And what we do is use kind of a weighted sampling technique to generate a ranking. So what I mean by that is first we collect all the scores for each of the comments, we normalize them, and we use this to select or sample a comment and put that in the first place. So the highest scored comment will not necessarily get the highest ranked spot, however, it has the highest probability of getting the first spot. And that's why we call this importance weighted sampling. And then we do this again. We do a sampling without replacements. We remove the comment we just ranked and do this again. Now this one we selected here did not have the next highest score, but was chosen by this random process. And we go on and on till we have selected all the comments. And now we have a ranking. We have an ordering of these comments. So the policy has given us a ranking. Now this is a random process, and the comments with the highest scores are usually up top and the lowest scores are typically at the bottom, but there's a chance that this moves around a little bit. And this is this inbuilt exploration, right? And that's important for us to be able to train this. So in learning, what we do is we have our model, we have our parameters that we want to train, and this gives us sets of rankings, the randomly generated rankings that we get, and we send them out in the world, and we collect rewards, right? So for different users, each user gets a ranking, and we measure the time spent on that particular ranking. The reward is dwell time, the total time spent, and then if we have the reward, we can start calculating a kind of a gradient ascent. Because we want to increase the reward, the dwell time, we do steps of gradient ascent, and we do this in the direction of expected reward. So I'm not going to go too deep into this, but this is kind of an example of a hypothetical reward landscape for this model. So the idea is that we can kind of start somewhere in this landscape, and we can take steps along this gradient and hopefully reach the top of the mountain, which represents the best solution possible. Now, this is obviously very simplified. Reward landscapes don't really look as simple as this, but still kind of illustrates how we try to train a model. To do that, we need to calculate the direction of the expected reward. I'm not going to go through that here, but we use a technique called policy gradient. But the important part here is that we have an expression with two components. One is the gradient part, the direction of the step that we're taking, and the other is the magnitude of that step, which is the actual reward. Meaning that we can kind of choose any type of reward that we want, since this reward is not kind of inside this gradient calculation. It doesn't have to be, well, differentiable. So we can use any type of reward, discontinuous, discrete, and even unknown, as we have here, and still be able to kind of ascend this mountain. Another nice effect here is that we can change our reward. If right now we're using dwell time, if we find that's too restrictive, we can change our mind and change reward types, and without necessarily retraining the model as well. But the non-mathy, sorry for the mathy parts, more intuitive explanation of what we're trying to do here is that if you have these different rankings, comments that are in rankings that give higher than average reward will be boosted up, and comments that consistently are in rankings that give lower than average reward will be boosted down, right? So the position of the comment in the ranking list that's the one that really gives us the direction of the expected reward, right? Because it's position bias. But how much reward, more or less than the average, gives us how much to step along this ascent, or this expected reward. So we need to have a system that takes the various comments that we have, has this scoring model, and is able to produce rankings based on this. And this is something that needs to be done real time, because these comments and upvotes and downloads, they can change very quickly. So we produce these rankings, we send these to some user who reads it, for instance, in some app or web page and so on, and which has been instrumented to measure how much time is spent. And then we send this reward to some distributed database. Very important is that when this ranking is produced to the user, we also need to log the features that were used to produce the ranking and the probability for the ranking being produced. These are two different data streams, and we have to do this because the reward happens at a different point in time than when the actual ranking was produced. So if you didn't log the features at the time when we're generating the ranking, the features could change in the meantime and so on. So these needs to be logged at different points in time. So we send both of them to this distributed database where these events are joined together. And then we can send this joined data to the machine learning system, which performs this gradient ascent step we talked about earlier to update the model parameters. And then this updated model is then used to update this scoring model in the ranking system. And this updated model is then used to produce new rankings, and so on. So that was kind of a high-level overview. The actual implementation was something like this. And this is a simplistic overview, but still. In the middle here, we have Vespa, which performs all the serving time functions. So on the right here, we have a user which engages with the presentation of the comments or web page. The user is viewing these different comments. The user can create comments, update comments, and so on. And this goes through comment processing and is fed to a Vespa instance, which holds or indexes all the comments, their metadata, and so on. When the user upvotes or downvotes the various comments, these are sent directly into Vespa as partial updates, so they can be kind of taken into account immediately. And the presentation is instrumented to measure the time spent. And when that is ready, this is sent to the distributed database on a Hadoop cluster. And when Vespa produces these rankings, it also logs these features and actions and probabilities and sends them to the same Hadoop cluster. So once every hour or so, we have a batch job that takes this data and updates the parameters of a TensorFlow model, performs some form of sanity checking. And if that passes, the model is pushed to Vespa, where it's immediately available for use in generating new rankings. So this is a loop that goes on every hour or so, and the model continuously improves. So we introduced Vespa a little bit earlier, but to reiterate a little bit, it has some important features for use as a comment serving system. First of all, it's scalable, it's fast, which is important given the traffic numbers of the solution. For instance, able to rank 10,000 comments in less than 7 milliseconds while evaluating this machine learning model. Write latency is very low. Other features that are nice is the direct deployment of machine learned scoring models. You don't need some sort of external model server for this, which is nice because it lowers the deployment complexity. Vespa supports machine learning frameworks such as TensorFlow, OnX, XGBoost, LightGBM, and has a kind of rather unique feature that you can kind of combine these different models together. So you can use advanced tensor computation to generate features that go into a TensorFlow model and use the output and send that into an XGBoost model and so on. And that's a very unique feature of Vespa. Easy to add custom logic. So that was added in this application for implementing sampling and logging. Also important is that within Verizon Media, we have a fully hosted solution. So users don't have to worry about things like hosting and operations, maintenance, upgrades, and so on. We take care of all of that. And with our CD process, we have 4 releases every week. So we're very agile and can fix problems very rapidly. We now also offer that to external users as well, our cloud solution at Cloud Vespa.ai. So if you're considering using Vespa at some capacity, we strongly suggest looking at that, as we believe it's the easiest and most safe and cost-effective way to run Vespa applications currently. So just kind of a very quick high-level overview of how Vespa works and how it works in this application. So in general, in Vespa, your entire application is specified in this something called an application package. You deploy this package to a configuration service, which then distributes distributes your configuration, custom components, machine learning models, and so on to all the kind of nodes of your distributed system. And this is live, so you can make changes without service interruption. The two central node types are the stateless container node and the stateful content nodes. The stateless container nodes, that's where you do your custom logic. You're able to do process queries or data before it's being sent to the content nodes. And the content nodes store the data and perform computation in response to queries. So the computation, including the evaluation of machine learning models, is pushed to the data rather than the other way around. So this scales much better as you don't have to push data across the network. So to scale up, you can just add new content nodes, which will distribute the workload on a larger number of nodes, thus potentially reducing latency as each node performs less work. And that was done in this comment ranking system, where we had, I believe, 32 stateless containers and 96 stateful nodes spread over 5 different data centers across the world. And we did that to lower the latency as we saw. So the results, I was going to show a nice graph here, but I kind of wasn't allowed to. But in the end, the result was a respectable 25 increase in time spent on average. So it was a fairly successful project. Going forward, we're experimenting with some more features for large neural networks, personalized comment rankings and so on, and more sophisticated rewards. Because right now, the only reward that we use is time spent, and that's a very, very singular objective. And that's kind of in conflict with what we talked about earlier, where perhaps content that provokes might be what actually causes people to stay longer, right? It's not necessarily these good and nice comments, but provoking comments, right? Actually, this was the premise of the documentary Social Dilemma, which you've probably seen on Netflix. And it's something that can lead to things like increased toxicity, divisiveness, polarization, flat earthers, I don't know. However, I'm not going to talk about this. That's a different talk entirely, very interesting talk. However, we did have features trying to combat this, but we need other reward signals as well. And we're working on that. So just kind of lastly, just really quickly, what I've been talking about here is comment ranking, and we created the system around this, but this approach really is totally generalizable to systems where you have some sort of machine learning model that ranks stuff and evolves over time. So this kind of implementation, this kind of system can be generalized to other types of systems as well, such as search and recommendation, ad selection, question answering, and so on. And really, it's a kind of approach or a convenient platform for anything where rewards can be measured and you need to evolve over time. So basically, this was the work of multiple teams across Horizon Media, not just us working on Vespa. So I hope I kind of done respect to the hard work of these guys as well. And with that, I'm a little bit over time. That was all. Thank you.
Thank you so much, Lester. This was so interesting. I am very curious about how such a domain-dependent technology can work for this specific sector. I'm also very curious how you balance the exploitation in your work. But before I do that, I should remind everybody that there is a poll, and you should definitely rank our first speaker there. And then after that, we can actually move to the real questions. And yeah, you know, actually, we have lots of questions for you, so maybe it's better we start already. Okay. I have one here from Armin, and he asked whether you use reinforcement learning from ranking in production, but I think a bit you already answered this, but if you want further explain. I think the main point of the question is whether this is good for research, but is it also good for real life work?
Excellent question. So yeah, the premise or the entire idea is that this would go into production. But there is this failure mode, if you will. Sometimes models that get trained in this loop are worse than previous iterations. So to combat this, we use the sanity checking, but also we use some sort of staged deployment. So basically, we have an A/B testing which tests this model with a 5% traffic, and if that shows improvements, we kind of move that out into to production as well. So yeah, this is definitely used in production, but there are safeguards in place, so the model doesn't kind of run totally amok.
So safeguards in place, you mean that there are also real people checking out that it's not...
Well, yeah, not real. Oh, yeah, it's tested on a small percentage of traffic.
Yeah, okay.
Yeah, and those are instrumented as well to see if the kind of metrics that we have don't deteriorate.
And building on that, can I ask you whether you have different topic in this article? So what is the area that usually this article you ranked are in? Or is there a specific...
This solution is totally general for all types of comments, really. So basically, if independent of the comments being on Yahoo Finance or sports, or whatever, it's the same system that uses this. But of course, these models are specified or are unique to their own domain, right? Because the interest of the community within these different properties, they're not as similar as in other properties as well. So they have their own models.
Okay, I see. Let me move on. Let's see, I have too many questions here. Just give me a second. How do you prevent the PG model to become deterministic? That's the next question from Laszlo.
By deterministic, you mean that it always generates the same rankings based on the model? Well, basically, it's this, we never drop this this exploration phase, right? And that's something that's important always when you're doing with reinforcement learning, is that you never, even though if you think you have a kind of a perfect model of the world or the environment that you're working in, the environment can change. So you need always to have some sort of exploration built into this. And this exploration is basically trying to, find different areas of the solution space so that you can continuously kind of improve. So while the learning itself is kind of fixed in how it does this using these reward signals, it's the way that we use this importance weighted sampling that ensures that we're, not kind of statically going into or painting ourselves into a corner in that way.
Makes sense. Well, actually, I have a little trouble here, so I don't know the next question, but maybe you can explain to us what you were mentioning at the end of your talk. So what are the next steps to improve the ranking?
Yeah, well, as I mentioned, we're looking at using more features, increasing the size of this neural network that we're using because it can express, a lot of different stuff that we have. We have many different types of features that we want to use, specifically within personalization, meaning that if you as a user tend to upvote a specific other user, for instance, then when this other user comments, then it should be a higher chance that you see their comments as well. Also, but not only person to person, but also on topic-wise as well. And as I mentioned, this comes with a fair bit of warning because we don't really want to go into the business of creating additional filter bubbles and deteriorating the fabric of society.
Yeah.
So we really want to kind of try to be careful with that a little bit as well. This is something that has seen a lot of press the last year or so.
Definitely a delicate topic.
Yeah.
I was also thinking whether you wanted to give us some extra on-the-field experience on some curiosity or something that happened in the first experiments. Have ever something gone wrong, for instance?
Actually, I can't recall any. This was a fairly straightforward project. I have to admit, the science part of this project, I wasn't there for all of it. I was more on the implementation side of it, so I tried to kind of recreate it as great as possible. But I would imagine there was a lot of kind of going back and forth to find the correct solutions there. But when we got to the implementation stage, it was actually fairly straightforward to implement all this because the kind of pieces of the architecture were very well known from other similar type of projects that we've done before. And that's always helpful. And also since we were using this hosted solution, then most of all the initial deployment and upgrades and so on, we've nailed that, to be honest. So actually, boringly so, I'm sorry.
Better. I have actually a question now from Caroline, and that is, how would you define the dwell time in this case?
Yeah, so dwell time is each page that the user visits, and particularly its comment section, is instrumented with JavaScript to measure the time spent that you use on this site. We have various instrumentation libraries that we use for that. And basically it tries to estimate the time that you spend based on your scrolling and where you stop and so on. So dwell time is basically just a measurement of the time spent on the content, really. So basically the main way you rank is based on the time, and you said you want now to improve and have other ways, so you will have to change this approach you have now with the JavaScript, right? Yeah, so that's part of the work. Exactly. So well, I mentioned this kind of singular objective that we have is increasing dwell time, which means we want people to stay longer on our sites. Definitely. And that's really a proxy for engagement, user engagement. So that's what we really want to do. We want to kind of increase our users' happiness in a way. Yeah. So actually, I was asking this because also Adi was asking whether you had other ways to score the comments based on interestingness. I guess the social bumble team comes back. Yeah, and definitely, right? So we have all these features that we put into the model, and we get the score on the other side, and we want to kind of be able to say that, well, hate speech, racist slurs, things like that. Those are things that we really don't want to give any score, high score to, right? So those are the kind of, that depends on the features that we use, really.
Yeah.
Ideally, we'd like to have some sort of features for, like we don't want to be able to spread misinformation and so on, but that's kind of a tougher nugget to solve.